Welcome to the Junctions Quick Start Guide. This is a short video for those unfamiliar with Junctions and wish to use it for the first time or returning to it after a long absence. To start, I'm going to show you how you can check you're using the latest version and take you all the way from opening the software to running a report. When you launch Junctions, having logged in using your username and password, you may be presented with a News Update window. This pop-up window will either tell you there is a new version available or that it is fully up to date. In this case, it says I am up to date. A link is often provided that takes you to where you can read about new features of the latest major version, and a second link that takes you to where you can examine in detail what had changed in this specific release. Having read the content, simply click the Don't Show Again option. This message will now be hidden until you launch a newer release. I'm going to start from scratch, so I'll make use of the Setup New File window that has appeared. This screen appears automatically when you launch the software or when you click the New File button on the main horizontal toolbar. I wish on this occasion to model a roundabout, so I'll pick that junction type and select 4 arms. It is the priority junction I wish to model, and I'm also interested in only one set of traffic data, so I'm leaving the other options as they are. Use of this screen is optional, as any selection made here can be changed elsewhere and later on. The options here allow you to create a basic skeleton file, however. By default, you will see the data outline appear. This is in the form of a tree structure and provides access to most of the data within my new file, and as you can see shortly, gives easy access to view or edit that data. Double clicking on any of the items in the outline will bring up the data editor. As I single click around the data outline now, I can access the contents of my data file through the data editor. Note how I can change the junction type here, as well as in the previous Setup New File window. I also have a bigger choice of junctions types available here. Let us start to enter some data now. The vertical toolbar is designed such you can start at the top and work your way down the page, but you don't have to stick to that. However, some choices make sense to choose first, such as junction type and number of arms, hence why I set this up to start with. The first button on the top opens the junction diagram. This is entirely optional, but can be used and offers some functionality that is not provided elsewhere. It's useful for showing some results graphically, and also contains a facility to assist with measuring geometric data. And on that subject, that is the data I'm going to specify now. The data requirements for modelling a roundabout are actually very modest. We need to enter only 6 basic data items per arm. As this is just a quick introduction to junctions, I won't go through what each of these are now. At the moment, the data shown is for arm 1. You have 2 options now. Either open a data grid. This will allow you to enter data across all arms. Or padlock the window to the data section roundabout geometry, and then click through each arm using the diagram or the previous next button on the horizontal menu. This is now padlocked to roundabout geometry, and as I click round, it goes through each arm in turn. With the diagram open, I can select the arm through this method as well. Please note that padlocks have multiple levels sometimes, and the second time you click on it will lock the window to a specific item, such as arm 3 in this case. Now if I click onto a separate arm, you will notice that it stays on arm 3. In fact, there's other layers available. If I click again, it will actually freeze the whole contents of the screen. If you want to unlock the window, simply keep clicking until the padlock reopens. When entering data, you should also keep watch on the errors and warnings button, as this button will turn red if data is not right, or yellow if there's something about the data that might need correcting. I'll demonstrate this by changing the entry width here on arm 2. Immediately an error has appeared because this is turned red. When I open it, it lists the errors on here, and maybe more than one. When an error exists, the traffic model will not run. Warnings, however, do not prevent the model running, but it's always worth checking the warnings to see what they say and change your data only if needed. I'll correct this before moving on by entering in an effective flare length here, which will correct the error in this file. Having entered my geometric data, I now need to confirm what pedestrian crossings I have on each arm of my roundabout. This is the next button down. I have a choice of none, the default, zebra, i.e. unsignalled pedestrian crossing, or a signal crossing type like a pelican or a puffin. I will assume in my file that I'm not modelling any pelicans or puffins or zebras, so I'll leave that as none. I will now need to specify my traffic demand. There are a lot of options here, but I will stick to the most basic one for my demo. I'm going to use what's called the 1 hour traffic profile. And this limits the data required to the volume of traffic arriving within the central hour of a peak period on each arm of my roundabout. As well as the volume of traffic, the model needs to know where that traffic is going, and this is easily provided by entering the data using an origin-destination grid, as shown on the screen now. So I'll now proceed to enter some information here. At this point, you might think I will continue to the next button on the vertical toolbar, the demand one, but as my chosen demand profile type is the default one, I can bypass this screen. Instead, I'm going to skip to the vehicle mix window. Although you can specify your traffic demand in vehicles or in passenger car units, the traffic model does want to know the percentage of heavy vehicles within that data. This is so that Junctions can readily convert the data from vehicles to PCUs and from PCUs back to vehicles, so that irrespective of what units you use, the model will have access to both units. This is so that the traffic model can give the most accurate results, because different parts of the model use PCUs and vehicles. I have completed the data entry, so it would be good to save my file at this point. You can simply press the Save button, give it a file name and press Save, or you can go into the File menu where you have a wider selection. For example, as well as saving to my own device or to localize storage, there's an option to save to the cloud. By default, all subscription customers are given access to a file storage area within the Terra software portal where they can store files. This area is useful as a collaborative space to share files with colleagues and optionally with clients as well. Irrespective of whether or not I have saved my file, I'm now ready to run the traffic model by pressing the Run Model button. As a core model is based on equations derived empirically, as well as having modest data requirements, they run fast, so results will appear almost instantly. When you run the model, the summary results window will automatically appear. that gives a good overview of the performance of your junction by showing the worst results across the model time period, which in this case is a 90-minute time frame split into 6 consecutive time segments. These time segments are accessed using the drop-down on the horizontal toolbar. The columns of the results in the summary results can also be changed, so you can remove items you're not interested in or add in new ones that you are interested in. Also on the vertical toolbar there is a results section. If you click on the drop down, it gives you access to the site time segment results. Or select whole period results to give you an overview of the total junction. Remember that you can also bring up a data grid to show results for all arms together. Now that we have results from the model run, we can also examine these in an HTML format report. Press the report button on the main menu, and in fact the file will rerun itself to ensure all the data and outputs are self-consistent. And here you get all of the input data plus a full set of results. One of the most commonly used facilities in the report is the ability to export the data to either a Microsoft Word format or to a PDF. Both are available from the Convert menu on the top menu here. The export to Word is not paginated, while the PDF is paginated, hence the latter gives you a client-ready report immediately. At this point, you might also want to investigate what impact certain input parameters have on the results. The last button on the vertical toolbar will bring up the Analyzer window. The Analyzer can be used to plot lots of different graphs, but a few XY graphs have been defined for you. All you need to do is select one of the common XY graphs and choose either line graph or bar chart. These can be used to check the robustness of your junction design, say to increases in traffic demand. I select the max delay versus flow scaling factor. This populates the input variables and the output variables required, and then press line, giving you a nice graph populated for each arm, showing you the max delay against network flow scaling factor. The raw data is also provided here, so if you want to copy that into some other system to present it in a different way, then that's also possible. I'm getting near the end of my presentation, so I will finish off with showing you where to go to get help when you don't know what to do next. First, pressing F1 or the help button on the horizontal menu will bring up the full PDF user guide. This is fully searchable and acts as a full reference to all the functionality within the software, as well as offering some sections to explain how to use particular parts of the software and to cover certain scenarios you might want to model. You will notice next to the help button is a glossary button. This is particularly useful when you need to understand the units used for a particular data input or results, or to remind yourself how to measure the geometric data. It's context sensitive. So having brought up the glossary screen, which is currently blank, if I now click through each of the data items on here, you will see how it gives you a definition of that item and also how to make that measurement. If you're looking at results instead, it will then give you again the units, but quite importantly it will tell you whether it's representing the highest value, the weighted average, just simply a number, or some kind of special output, which is obviously on here, showing you the max level of service. So particularly useful feature. Also, if you cannot find a particular input data item in the data outline or a result value, you can access the data field finder from the help menu. F3 will bring up the same screen. I'll type in delay, press search, and it gives me a whole variety of different results or inputs with the word delay on it. I'm interested in the delay result here. If I double click on it, it will take me to where that is. Also under the help menu, you have access to our online knowledge base, which is based on our TRL software website. And if you still require assistance, all subscription license holders also have access to TRL software support service. This concludes my presentation. I hope what I have demonstrated illustrates how easy it is to set up a basic traffic model in Junctions and run it to evaluate your chosen junction type. I'm Jim Binning, and that concludes my presentation. Thank you for watching.